So for the observation, you see that salamanders near the pond have curved tails, not straight tails. Now you want to think, why is that? So why might that be? Are there any explanations? You guys want to give me an explanation? You can type in the chat. I have that open. So why do you just think of anything? Why you think might that be happening? Keep in mind it's near a pond, so maybe it has to do something with the pond. So I'm looking at chat, environment. Is there anything specific in the environment? Maybe something in pond water. It's more hydrated. Okay, yeah, that's a good one. Water temperature. Okay, so you're gonna think of the reason, and that's gonna be your hypothesis. So it must be testable, and if it's written as if and then, it's more of a prediction. So an example would be that maybe the salamanders have curved tail due to a pollutant in the moist soil where they live. Or like some of you did give me a really good ones, maybe it's because it's more hydrated, or maybe it's the water temperature. But any of those can be a hypothesis, but it has to be testable. So now you have to come up with a procedure to test the hypothesis. So how can you test, let's see, the first one. How can you test the water temperature one? How can you test that? Again, you can just type your answer. So you can also unmute yourself and say it on temperature gun, or you can also, you're gonna have to get a control thermometer. So you're gonna have to get a control group as well with this. So you wanna test the salamanders for the water temperature. You're gonna have to have different temperatures. You're gonna have to have a control group, and then you're gonna have to keep the salamanders there for a timeline, and then you can test that. That'll be a type of a procedure that you can come up with. And then there are different variables you have to keep in mind. I said, first one, let me see, control. So there has to be a control group always. Whenever you're doing a test, you have to have something that you can compare it to. So always you're gonna need a control group. So otherwise you will not really know. So I was talking about the vaccine. So if you didn't have a control group, you wouldn't really know if it made a difference. So to see if it actually works, you have to have a control group. So the experimenter changes one factor and observes or measures what happens. So let's say, going back to the vaccine example, you change the dose or the amount of vaccine that's being given. So if you increase it, you're gonna go ahead and measure what happens. Maybe less people get sick, maybe more people get sick. So however one variable is changed, it's gonna affect the other variable. So there's an independent variable and there's a dependent variable. When you change the independent variable, which is the dose of the vaccine, it's gonna affect the dependent variable. It's gonna change the number of people. It's gonna cause some type of difference in the measurement. And then you're gonna try to keep the control group constant so they're not affecting the outcome. So those are the control variables. The purpose of the control, they're not being tested, and therefore the comparison. So you have something to compare to. And again, two other variables, you have independent and the dependent variable. Independent, that can be changed, and if you manipulate independent variable, it can affect the dependent variable. So we have three variables so far. We have control, that's gonna stay the same, standardized. Then we have independent, and we have dependent variable that's gonna be measured. So another example I have for you, let's say you want to figure out the fastest route to walk home from school. You will try several different routes and the time, how long it takes you to get home by each one. Since you're only interested in finding a route that's fastest for you, you will do the walking yourself. So that's the control. You're gonna see how long it takes you. So varying the route, so using different routes is an independent variable, and the time that takes is the dependent variable. So route, independent, and when you change the route, it's gonna affect the dependent variable, which is the time. That's something that you're measuring. And then keeping the same person who's doing all this, that's the control variable. So you do it yourself, that's your control. You're the same person who's walking all the routes, that's your control. Now, if different people were doing it, this experiment would not be valid. And then you always want to have several trials. So again, if you were testing a vaccine, you want to have a good sample size. And then you want to repeat the trial. So bigger the sample size, better the accuracy of the results is. And then you want to do it a few times to confirm the accuracy and to support the hypothesis. So 2 groups are required, at least 2. So that's the minimum, the control, and then the experimental groups. There should be 1 variable, so it needs to be control variable, and then the data. So you need to collect the data, and it can be quantitative or it can be qualitative. I think that's all. And then last one is the answer to the hypothesis based on the data. So you can't just say, oh, this is how it is. You have to look at the data and you have to do a type of test that needs to be done, maybe chi-square, maybe t-test, maybe ANOVA, different type of test. And those tests are decided depending on the type of experiment it is. Let's say it's a quantitative experiment, maybe you're gonna do ANOVA. If it's a qualitative, maybe there's a way to do a chi-square. And then from there, you're gonna get a p-value, and that's gonna either support or reject the hypothesis. And then you're gonna retest it. Even if it's supported, you wanna still do a retest. And if it's rejected, maybe you can change a few variables in your experiment and you can do the retesting again. And this is the last slide I have. So you're gonna observe something, you're gonna write a hypothesis and maybe a prediction. Hypothesis and prediction, they kind of go hand in hand. So if you're saying, oh, if the pollution is affecting the salamanders, then they should have curved tails or something. So depending on what your hypothesis is. Then you're gonna design an experiment which has to have a control group, and you're going to collect data. Also, when you are designing an experiment, you want to write down your independent and your dependent variable. You're going to collect data, do a data analysis, and form a conclusion, and that's going to either reject or accept your hypothesis. From there, you're going to go for a retest. So I'm looking at chat now. If you want to type your questions, I can answer it, or if you want to unmute yourself, you can just ask a question. Yes, so let me share my screen. So for the Canvas, you want to go to McGraw-Hill and you want to go to my Connect section. So that's going to sync it with your Canvas. So mine's already linked, so that's why I'm saying go to my Connect section. For you, it's probably going to say launch. Okay. Yeah, if you don't do it through Canvas, I'm not going to be able to sync your grades. So even if you complete the assignments, your grade's not going to show on Canvas. So make sure you do this. And I see some of you got the 2-week trial. Make sure you guys, get the access before your 2 weeks end if you decide to stay in the course. Otherwise, it's just gonna, disappear. And then if you go on home page of your section, it's gonna show you what's due, and this is what's due. And the only new thing I added was the lab safety contract. So please sign that and upload that whenever you can, or by the 4th. So this is all I have for the lab. Oh, another thing I want to mention, if you have hard time with your computer, the labs are not loading, you can use Chrome. Chrome works a lot better with Labster and McGraw-Hill compared to Safari or Firefox or other browsers. So it's gonna, and then also one more thing, you want to always delete your cache before you launch McGraw-Hill or Labster, because it's not gonna load otherwise, or it's gonna take forever. So that's gonna help you speed up the virtual labs. And you can also, when you go to discussion, you can view the rubric as well. So please answer the questions that I'm asking. So you can click here, you can click show rubric, and it's gonna show you what's expected and the number of points you're going to get depending on what you answered. So make sure you're covering all the points that I'm asking here. So that's one way to make sure that you're getting, all the points and doing good in this class. And I think it also should let you edit your discussion answer if you already answered it, if you want to add something. So go ahead and search Kahoot, that's how you spell it, on your app store. You can use the app store and download this app. So let's see, let's get you started on this here. So let's see if you guys can log in. That's the pin. So I'm just gonna start it. So this one is on scientific method, we just covered that. So what is the first step of scientific method? So now first you have to do the observation, question, or the problem. What are you trying to figure out? So that's going to be the question or the problem, or like salamander tails or curved. So that's, you observe something. So after that, you're going to form the hypothesis. So this is the second step. So what is another name for scientific prediction? So that's the if and then statement. Hypothesis. Everybody got it? Most people. In what step of scientific method do we decide whether a hypothesis was correct or not? So that's going to be the last step. Conclusion, that's correct. And one person said research and observation. This is the first step. Observation is the first step. Observation, question, then hypothesis, then experiment, then conclusion. Oh, I'm going to skip this one. That is correct, the hypothesis. The last question. In what step do you establish the purpose of your experiment? So this is basically asking, why are you doing that experiment? Question or problem. So you have to decide why, and then you have to answer the why in the hypothesis. Usually sometimes they say that you write the hypothesis and you have to have the word because in the hypothesis, and that's because you're trying to answer that why. So why are you doing this experiment? So you have to know that before you start the experiment. So that's the question or the problem.